Okay, we are back. Sorry for that rather abrupt ending. Our 15 minutes went by so quickly. We are back here with dominance testing. And if you can recall, we said that stochastic dominance does not prevail over this full income range when looking at Gauteng and the Western Cape CDFs. And why does stochastic dominance not prevail? Or why does first order dominance not prevail? Well, that is because the lines do intersect. However, if we have to cut off this range, the income ranges, let's say from 0 to 5,500 per capita income, where they do cross, and we only look at that segment of the income range, over there we can see that dominance testing does prevail. That stochastic dominance does prevail, and that the Western Cape or Gauteng is relatively poorer than the Western Cape. And then after, if we change the income range from about 5,500 to 10,000 per capita income, if we just look at that range, we can say there is stochastic dominance with the Western Cape being relatively poorer. Okay. But if we're looking at the full income range, we cannot say that first order dominance exists here between these two provinces. When looking at their CDF, there's no stochastic dominance. What we then need to look at is second order dominance, which would involve measuring the area under each of these CDFs and then comparing to see which one is larger or which one is smaller, and the one with a relatively larger area under the CDF, that province would be relatively poorer for all poverty lines across this income range and for all FGT measures. Okay. So we can play around a little bit more here. We see there's quite a lot of intersections in between. So what you could potentially be asked in a practical, for example, is to describe how the ranking of poverty changes when if we look at different poverty lines, right? So let's say we want to look at the ranking ranking of relative poverty between, let's say, Limpopo, what's this green line, Northwest, and the black line, Western Cape and Gauteng. So if we want to look at the ranking over there of welfare, and we choose maybe, let's say, a poverty line here of 8,000 per capita income. Okay, so now I'm only going to look at what is happening with the CDF after that 8,000, and we can see that if I look at 8,000 as my cutoff, how are they ranked? Okay, so as mentioned before, on your x-axis, when you're looking at either income or expenditure, often it's expressed in per capita terms, real per capita terms, and most of the time it is also logged, and you can see that the shape looks slightly different when it is logged because it's more normalized with a log distribution. But if we look at the CDFs, you don't only need to look at it by province, you can look at it by race, by gender. Over here you've looked at it by year to see how poverty has maybe changed in one country across different years. And if we look, for example, at 1993 and 2004 year, you can see that the blue line and the yellow line, they never intersect. So stochastic dominance or first order dominance prevails here, and one can definitely say that in 2004 this country is less poor for any FGT measure and even any poverty line when compared to 1993. And you should see the same thing when you look at the CDF in a non-log graph. You can see that the yellow line of 2004 and the blue line of 1993 do not intersect, so it is robust to any FGT measure or any poverty line in analysis. So this slide really highlights the problems that we may encounter when having to choose different poverty lines and how that impacts different poverty measures, because policymakers often want to understand the effect of a grant on poverty. And if you look at the different FGT measures over here, P0, P1, P2, same on this side, you can see how much they vary by the poverty line that was selected when looking at these poverty measures without the grant and with the grant. And the effect here caused by the grant will differ quite substantially depending on which poverty line you choose. So if you were in government and you wanted to say, yay, we did a great thing, we've got grants, and look at the big difference our grants made, you would probably opt for a poverty line of 515 Rand per person, because it shows that your grant has had the biggest effect on poverty across all these poverty measures. But in reality, this might not be the best poverty line to choose. If, depending on the context, maybe a more realistic poverty line would be 949 Rand per capita. So you can see how hard it is sometimes to choose an exact poverty line. In South Africa, we tend to use bands, upper and a lower band. But dominance testing, where we start ranking different subgroups and, to try and understand how poverty differs, that can also be used when we look at how poverty changes when a grant is introduced or not. Okay. And right here we have an example of that. We instead of using poverty lines and measuring each of those FGT measures, we simply use cumulative density functions. In this example, it's for Namibia, and we use this instead to try and understand what the effect of a particular grant is on poverty. And you can clearly see over here, if we look at the pink line, which is the per adult equivalent expenditure without grants, and the blue line is with grants, you can see that stochastic dominance prevails here. That means irrespective of which poverty line is chosen, maybe the upper bound poverty line or lower bound, it doesn't matter, but the society will always be worse off or poorer for any FGT measure at either the upper bound poverty or lower bound. In fact, any poverty line, the expenditure without a grant would always leave society poorer than expenditure which includes a grant, which you can see lies below. The blue line lies below the pink line, so there is less poverty throughout this income range at any poverty line and for any FGT measure. So this would be a superior approach to trying to understand the effects of a grant without having to specifically choose a poverty line. Okay, this slide basically just looks at the effect of the social grant on one FGT measure, specifically poverty headcount ratio, which you know is P0. And this just shows you that there are many different ways of visualizing your data or bringing your message across to your reader. And so over here with these bar graphs, it looks at how the effects of these graphs looking at the lower poverty line and the impact of the social grant on, or the social grant on the poverty headcount ratio. So including social grants, it's at 20%, but if we exclude social grants, it's 26%. So you have more poverty when we don't, distribute social grants in Namibia. This is using your lower poverty line. Looking at an upper bound poverty line, we find here that when we include social grants, the headcount poverty ratio is at 38%, and when we exclude it, it's far higher, it's at 42%. And so you can see the huge difference in the poverty headcount ratio. The effect of social grants are depending on which poverty line you use. And again, just another example where we have a table now instead of bar graphs, where you've now put your FGT measures, all of them, P0, P1 and P2. You have calculated for both lower bound poverty and upper bound poverty lines. And here you can see the effect that the grant has on these different FGT measures. And again, you can see how it differs depending on which poverty line you choose. Okay, so we are now going to move on to inequality and measuring inequality. And what we need to understand is that we measure changes in inequality because it helps us to determine how effective policies are that are aimed at changing inequality in a society. And it also generates the data necessary to use inequality as an explanatory variable in policy analysis. Now, just to recap some of your undergraduate work, you remember if one person holds all of a given resource, inequality is at a maximum. And if all people hold the same percentage of a resource, we can say that inequality is at a minimum. So inequality studies will explore the levels of resource disparity. And so therefore we don't only look at inequality over income, even though that is the one we look at most often. But we explore the levels of resource disparities and both their practical and political implications in society. We are mainly going to focus on size distributions, Lorenz curves, and Gini coefficients when we look at inequality. I will end off this video clip right now because we're running out of time. But a lot of the work that we'll be going through here, you have come across before, so there are a few slides that I'll just skip through and you can do that for self-study, and I'll focus more on the newer application of using Lorenz curves and Gini coefficients along with concentration curves later on, so that you can understand how government interventions can change these measures.